Hi everyone! So this is a continuation of our section 3 video from last time. This is part 2. So as you can see in my notes, this is just a continuation literally from the last time's notes. So we're talking about sampling techniques today because for last time we said that when we set up an experiment, we wanted to make sure that we have random assignment, we have good sample sizes, things like that. So sampling techniques is like, how do we pick our sample? Because we want to make sure we have like a good representative group of people, because anytime we're doing studies, the whole point is to not ask every single person that we want to study, like, what if this vitamin is working, if this drug is working for you. We just want to pick a small group of people and then figure out if that drug or whatever works for them and see if we can generalize that to the whole population, because otherwise it would be too costly. So when we pick a sample, we want to make sure that our sample consists of people who are, represent everybody else in the population. So maybe like a good range of age groups, different ethnicities of people, different, all sorts, so that we can really use that information from our sample to generalize to the whole population. In order to do that, we have several methods. And so our techniques is, the first thing is just a random sample is what we want, because if we have a random sample, then we make sure, like kind of like that random assignment, we can eliminate any confounding variables. That's the goal. So a random sample just describes a sample where every member of the population has an equal chance of being picked to be in the sample. And this concept is actually very idealistic, because in real life, you can't actually go up to every single person who you want to be in the population and be like, you're going to be picked for the sample. Because if that person, can't do it or whatever, or can't be in the study, then you really are out of luck there. So it's not the most idealist, or it's not the most realistic, but this is ideally what we want. So, random sample is kind of like the overall description of the rest of these methods. So the next few are considered random samples. So the simple random sample, this is like the most basic one. And then we start getting into more like realistic ways of how we can choose a random sample. So the most basic, most simple way to do this is a simple random sample. We like to abbreviate this with SRS because simple random sample is too long to say. But basically, in a simple random sample, every possible sample of the same size has the same chance of being selected. So this is different than every member has the same chance of being selected, like we had in the definition for random sample, because in a simple random sample, we want to make sure that for whatever group size that you want, so let's say we wanted a sample of size 10, for that sample of size 10, those 10 people, no matter who I pick, that grouping has to have the same chance of another grouping getting picked to be in the sample. And the easiest way to do this is to actually put everyone's names for everyone in the population, put them all in a hat, and then just keep drawing out names until you get enough people to be in your sample. So this is the simplest way, because this is actually not really realistic. If our population is like, we're trying to study all Americans, how are you going to get every single American's names into a hat? Maybe a giant bucket, but even then, like, that's too many names. So a more realistic way we actually do this is using technology. Instead of writing everyone's names, that's going to take forever. We can use something called a random number table. So if you look below, I have an example of a random number table. There's actually, if you ever just look up random number table, it's literally just a page, more pages, filled with just numbers. Numbers on numbers on numbers. So I just took one line of the random number table and printed it out for you here. But in a random number table, what we want to do is have this randomly populated number table to use numbers to represent the people, and then choose random numbers, because technology is better at choosing numbers versus choosing names. So even if we use like a computer or something like that to choose random numbers for us, it's a lot easier to do that. So for us, because we're in class and I don't have a random number generator to use for all of you guys to use, so we'll be using a table instead because, you know, slightly lower tech. So what we want to do with a random number table is to assign every person in the population a number. Once we've given everybody a number, then we want to look at the table, and I said look at the random number table using blank digits at a time. The way we determine that blank depends on how many people are in your population in general. So let's say we're trying to do a study about West Broward students. So the entire population of West Broward students would be like, what, 2,700 kids or something? So the total number, 2,700, includes 4 digits. That means we would give every single student a number with 4 digits in it. So like numbering from 1 all the way to 2,700. So even when we use the number 1, we want to make sure that there's 4 digits total. So we would use like 0001, and then the next kid would get 0002, and so on, all the way to 2,700. At that point, then using the random number table, we want to look at 4 digits at a time. So always use the same amount of digits as in like the total amount of people that you have. Because if we did that, then like looking at 4 digits at a time, the first number I would see would be 1,646 using this random number table. So that means whoever had that number or whoever was assigned that number, they would be chosen to be in the sample. And then I would pick the next 4 digits, that would be 0482. Whoever got that number, they would also be in the sample. And I would continue this method all the way through until I've chosen enough people to be in my sample. So that makes it a little bit easier to pick people, where it's still very random. It's kind of like drawing names out of a hat, just with numbers instead. So the next type of random sample is called a stratified sample. So here it's a little bit more complicated because we're going to group our population into different categories first. So once we've grouped them, then we select a few from each group. And what this does is actually gives us a little bit more representative of a sample. Because let's say I'm trying to study West Broward students again. So my population is all West Broward students. I can group them by grade level, so freshman, sophomore, junior, senior. Then I can pick samples based on their grade levels. So I would pick a few of the freshmen, a few of the sophomores, a few of the juniors, a few of the seniors to be in my sample. That way, in my final sample, I have like a good spread of all the different types of grades. And that way, in my sample, then I make sure that everyone is included. When I make generalizations from whatever comes out of my study, then I can say like this works for freshmen as well as sophomores, juniors, and seniors. So this is a nice advantage of stratified samples because in a simple random sample, because we're just randomly drawing names, it is very possible that we end up with a whole bunch of seniors, some sophomores, and not very many freshmen or juniors or something like that, just because it's so random. And so with stratified, we basically guarantee that our sample is going to include some of every group, which is nice. The next type of sampling method is the cluster sample. So the cluster sample is kind of similar to stratified, and a lot of people mix these two up a lot, so you want to be careful with this one. The cluster sample, you're still going to group the population into categories first. These categories that you've grouped them into is also called clusters this time. So in cluster sample, we have groups called clusters. In stratified sample, we have groups called strata. So with these clusters, rather than picking a few from each cluster, we're going to choose an entire cluster to be in the sample. So what this looks like is if we're using West Broward students again as our population, then if we group them by category or by grade level, then we would choose like all of the freshmen or all of the juniors to be in our sample. This might result in a really big sample. It might not. That really depends on how you group them. Another way we could group would be like if we chose like if we group them by first period classes. So whatever class you had for first period, we would choose a few first period classes. So randomly choose like Miss Fernandez's first period class, and then randomly choose somebody else's first period class, and those people, those clusters would be in the sample. So cluster is like you choose everybody in that cluster gets to be in the sample, versus stratified, only a few from each strata, a few from each group get to be in the sample. So cluster is more for convenience, because a lot of times clusters are based on location. Like if we said like first period classes, then if I were to give a survey or something, then it'd be a lot easier to just go into like a few classrooms to then give the survey. Broward does this a lot with their surveys, like Broward County in general. They like to choose specific schools to do surveys. So rather than getting every school to participate in their survey, they just look at a few schools. And so in that case, the clusters would be each school. So they're already grouped by school, and then they would choose like West Broward to do the survey, and they would choose like Flanagan to do the survey, but not the other high schools, something like that. The next sampling method is called a systematic sample. So in a systematic sample, instead of grouping people, we're going to just get a list of the entire population. So if West Broward students is our population, we would just get a list of all the West Broward students. Then you're going to choose a random spot within that list to be your starting point. So somehow you've chosen, like, I don't know, the 10th person down or whatever. Then you're going to choose your people based on a pattern. And when I say pattern, I mean like if we go down the list and choose like every 10th person or something, or every 5th person, something like that. Just depends on how many people you want in your sample to begin with. So because you're going by like every other person, every 10th person, every 100th person, something like that. That pattern right there is what makes it a systematic sample. And finally, our last method is not a random sample. So let me make that very clear. This convenience sample is not a random sample, because like the name says, it is based on convenience. So convenience sample could just be choosing like your friends to be in your sample. It could be like the first few people to walk into the school or whatever. That would be a convenience sample. So when this happens, this is bad, because a lot of times based on convenience, those people tend to have very similar opinions, or they're similar in some way, because you've chosen your friends because they are similar to you somehow. Or like if you're looking at the first 20 people to walk into a school and you want to use them for your sample, well, these people are probably, they probably have a certain transportation system, and that's how they're so early to the school. So all of these similarities would really bias your results or your survey. So if there's bias in your studies, then that means your results aren't going to be very accurate. It's going to be hard for you to generalize your results to the whole population, because you've chosen a sample of people that was pretty specific, had very close similarities, stuff like that. So really the only people you would be able to generalize your findings to would be your friends, or the people who show up early to school, or something like that. But those are all the different ways that we can choose samples. Try not to choose a convenience sample. That's it. Thanks for watching, guys. Have a great day.